Good afternoon and welcome, and thanks for joining us for today's media teleconference to provide an update on the agency's Boeing Crew Flight Test and International Space Station operations. I'm Josh Finch with NASA's Office of Communications. Our briefing participants with opening remarks are Ken Bowersox, Associate Administrator, NASA's Space Operations Mission Directorate, Steve Stich, Manager, NASA's Commercial Crew Program, Bill Spetch, Operations Integration Manager, NASA's International Space Station Program, Emily Nelson, Chief Flight Director at NASA's Johnson Space Center, and Mark Nappi, Vice President and Program Manager, Commercial Crew Program at Boeing. Although not providing opening remarks today, we are also joined by Joe Montalbano, the Deputy Associate Administrator for NASA's Space Operations Mission Directorate. We'll go around from opening comments from each of our speakers, and then we'll turn it over to the question and answer portion. We are asking today that we get to one question per outlet, and then we'll come back around as time permits within the hour that we have for today's media briefing. With that, we'll go for opening remarks to Ken Bowersox.
Hey, thanks everyone for joining us today. I know you're all busy, and we appreciate the time that you're spending with us. There's a lot going on in low Earth orbit at the International Space Station and around our planet. We've got the Starliner up there. We've been trying to do some EVAs at ISS, and we also announced a provider for our US deorbit vehicle. So we thought we'd talk a little bit about all those things today, but mainly focus on the Starliner. We have a beautiful platform up there in orbit, the International Space Station. We do great science. We learn all kinds of new things about operating in space that are going to help us with future exploration going out to the moon and onto Mars. It's interesting. Everybody seems to see the space station a little bit differently depending on what's important to them. As a crew member, one of the things you see about the International Space Station is it's an outpost in a hazardous environment. Once you're there, things change and you have time to relax a little bit. If you're on your transport vehicle, you're generally pretty time limited, but once you arrive at the space station, the resources are they're still limited some, but you can stay up there a lot longer. We have the luxury of time. So with the Starliner mission, you may remember back in the post-launch press briefing, I said nobody should get too excited about any particular landing date because once we got up there, we might want to look at some data a little more closely. We might want to wait for weather, but we were going to make sure that the conditions were right to bring Starliner home. And one of the things I really like about what our team is doing is they are taking that time to go through the data we gathered on the way uphill, to see if there's any additional testing or analysis we want to do to understand our risk posture, but also to see if there's any extra data that we want to collect on the return home. But everybody should understand we're still in the middle of a test mission. We're still pressing forward. We're still doing all the work that you need to do to have a successful test mission. It's been so impressive to watch our Boeing and NASA teams as they work through everything with this mission. I've been really proud of them. I've been proud of their expertise and proud of the patience they're displaying as they work through the data that they're gathering and think about what they want to do as next steps. There's a lot of details that we can share about the work that's been done, and I'm going to pass you over now to Steve Stich so he can share some of those details.
Yeah, thank you, Ken, for that introduction, and thanks to all of you today for tuning in and supporting our commercial crew program, and appreciate your interest in Boeing's crewed flight test. What we hope to do today is maybe clear up some information that's been out there and any misunderstandings about the flight and our status of Starliner and our path forward. First of all, there's no new issues to report today. We don't have any new problems we're working with Starliner or the International Space Station, so the vehicle at station is in good shape. I want to make it very clear that Butch and Sunny are not stranded in space. Our plan is to continue to return them on Starliner and return them home at the right time. We'll have a little bit more work to do to get there for the final return, but they're safe on space station. Their spacecraft is working well, and they're enjoying their time on the space station. I want to reiterate also that Starliner remains available in cases of an emergency or a contingency on the space station where the crew would have to return very quickly back to Earth. And as an example of that, on Wednesday night, unfortunately, there was a satellite breakup in an orbit that was lower than the space station. And so the standard procedures at space station, if there's any risk to the space station as a result of that breakup, we have the respective crews go to their lifeboat vehicles, the Soyuz, Dragon, and Starliner. And in fact, we used Starliner for that safe haven capability. Butch and Sonny got in the spacecraft, powered the vehicle up, closed the hatch, and we're ready to execute, should they need to, an emergency undock and landing. So the vehicle remains safe, and Butch and Sonny used it, and it was great learning for us while we're docked at the space station to have this contingency come up. Obviously, we don't like these orbital debris situations, but it was great to exercise that. We've done that before with Dragon and our other vehicles. I also want to make it very clear it's a test flight, and we expected to learn about the vehicle, and that's really what we're about right now while the vehicle is docked at the International Space Station. We're about learning, and now we're embarking upon almost increment operations at the space station, and so we're not discouraged or deterring from learning while the vehicle is docked at the space station. We continue to work together with Boeing to improve our understanding of the two issues that we've been talking about, and I'll go into a little more detail on that before we step into the final return at the end of the mission. Remember, we don't get the service module back, so anything that we can learn on orbit is very important, not only to this mission, but future missions as well. I want to make it real clear that we're not in any rush to come home. As Ken said, the station is a nice, safe place to stop and take our time to work through the vehicle and make sure we're ready to come home. We talked about a 45-day limit pre-flight, limited by the crew module batteries on Starliner, and we're in the process of updating that limit. Essentially, the risk for the batteries is the same any given day on station, and so we've been looking at those batteries and their performance on orbit. They're getting recharged by the space station, and that risk hasn't really changed. So the risk for the next 45 days is essentially the same as the first 45 days, and so we'll go update that limit. I want to reiterate and remind folks that Starliner is really designed for a 210-day mission, and the systems are performing well. So with the extra time on orbit, we'll be watching the vehicle. We'll be watching the way the heaters work on the prop system. We'll be watching the way that the space station continues to power the vehicle, characterizing the thermal performance of the vehicle, and then obviously Bill Spetch will talk about all the activities that Butch and Sonny are supporting on the ISS. Now let's talk about the two areas that we've been focusing on. One is the helium leak. I just want to remind everyone we're not leaking any helium while we're docked to ISS. We have those manifolds closed, so we're not using any consumables in that area while we're docked. We did a leak check back on Saturday, June 15th, and the leak rates actually went down in all the manifolds, all the 5 that were leaking. So now what we're doing is we're taking our time to govern by the fall tree that we put together, to look through the system, to analyze data, and to close out blocks on the fault tree. I know Mark will talk more about that. We're going to continue to verify the helium margins and double-check those before we undock. We'll review the management of the system. In fact, a few days ago at the Starliner Mission Management Team, we talked about the crew's capability to respond to a leak. We wanted to double-check the software, double-check the items in the software to make sure that was correct for return. And then we're going to do more testing on the ground. We've done some testing already with this flange that we talked about pre-launch and the seal on those flange. We've applied heat to those seals to simulate thruster firings. We've damaged some seals and done testing, and we're trying to make sure we understand exactly the root cause as best we can on the ground. We'll also do some testing at White Sands to understand exposure to hypergol vapors. We don't think that's happening, but we want to just double-check that item on the fault tree. And then finally on the ground, we're also disassembling several thruster flanges to see if there's any causes there related to improving our understanding of the leaks that we're seeing on orbit. So again, nothing has changed with the leak rates. We're in exactly the same posture we were. We have the margin we talked about before. We need about 7 hours of helium to get undock and get to the deorbit burn and the SM disposal, and we have 10 times that margin. On the thrusters, we're taking our time while docked to look at all the data from all the previous flights. On the Orbit Flight Test 1, we had some very aggressive thruster firings on that flight in the early phase of the flight where we had a lot of heat put into the thrusters, and we're working through that data. We want to have extra time as well. We did the dock hot fire a number of days ago, Saturday, June 15th, and we're analyzing all the data from that. It's difficult to get the precise measurement of thrust that we would like, that our thruster engineers would like because of the massive size of ISS. But the team's done a great job, and we know that the thrusters are performing somewhere between 80 and 100% of the thrust on each thruster. And they performed well during the rendezvous and docking. In fact, one thruster actually fired after we had hot fired it on the docking day another 575 times. We worked to look at the imagery that we took at ISS with the robotic arm, and we didn't see anything off nominal there. Any of that imagery looking into the throat of the thruster, looking for erosion or anything that would be an area of concern. Given all the data we've looked at so far, we want to embark upon a test campaign at the White Sands test facility to replicate a thruster firing that we've seen during flight. So we've picked a thruster. We'll go put that thruster, a new thruster, through the same profile that we saw on the uphill phase from on-orbit insertion all the way to docking. We'll recreate that profile. Then we'll put a pretty aggressive profile in the thruster for the downhill phase, and then we'll give engineers a chance to go look at that thruster and take a look at it and make sure that there's nothing that's unusual about the thruster. And so that's the one new thing that we're talking about today that we haven't talked about before is a set of thruster testing at White Sands that starts. The thruster is already being put into the chamber. We should get into the first, what we would call acceptance testing, which is a normal kind of test, as early as Tuesday the 2nd, and then probably a couple weeks of testing with that thruster to understand its performance. And this will be the real opportunity to examine a thruster just like we've had in space on the ground, the detailed inspection. Once that testing is done, then we'll look at the plan for landing. We don't have a targeted date today. We're not going to target a specific date until we get that testing completed, and we look at the fall tree, and then we understand the path forward. So essentially it's complete the testing, complete the fall tree, bring that analysis into this SMMT, and then have an agency-level review, and then we'll lay out the rest of the plan from undock to landing. I think we're on a good path. I want to thank the Boeing, the NASA teams all across the country working so hard on CFT. They've been working for many long hours. We're starting to, in the increment phase, give them time off, which is well-deserved. They continue to dive into all the details of the fault trees, close out the blocks, and again, we'll update you when we get the results of some of the testing, and then we'll lay out a path forward for landing. And I think with that, I'll turn it over to Bill.
All right, thanks, Steve. And I'll give you my thanks for everyone joining us today. It's been a really busy week here in the space station world. As you guys remember, we attempted on Monday to go out on a spacewalk with Tracy and Mike, and that one ended early due to a water leak at the service and cooling umbilical unit that was attached to Tracy's suit. After she detached it, it started leaking. And so that led to a lot of water in the airlock. The team continues to investigate what was going on with that, what caused it. When we came back inside, we weren't able to recreate that failure, so we're continuing to look at that. Given that, we're currently targeting the end of July for our next EVA, so we want to give the team enough time to go understand what happened on this one and make sure we don't have to make any changes. That spacewalk will actually be a different one than what we're trying to do on this last one. We're going to go out and relocate a communications antenna. We'll conduct some preparatory work for the alpha magnetic spectrometer, looking at some changes that they're going to make to that one down the road. We're going to replace a rate gyro assembly, and then we will actually try to conduct some swabs of the outside of the space station looking for microorganisms. As Ken mentioned earlier on Wednesday, we did announce that SpaceX had been selected to develop and deliver the U.S. deorbit vehicle, which will provide the capability to deorbit the space station and ensure we avoid the risk to populated areas. This was really important as the agency continues to work to transition to commercially owned space destinations closer to home. We have to be responsible and prep for safely deorbiting the space station after its end of operational life. Then, of course, on Wednesday, as Steve mentioned, we did have the satellite breakup event nearby us at around 8:45 Eastern Time. We instructed the crews to shelter in their respective spacecraft as a standard precaution for when these events can happen. They don't happen very often, but if they do, we take that step. The mission control team monitored the path of it, and after about an hour, we were able to clear the risk to the crew and have them exit their spacecraft, and we resumed nominal operations. We now understand that that was a commercial Earth observation satellite which launched in 2013 and was decommissioned in 2021. Space Command will continue to monitor the debris field as we work together. So Sonny and Butch are staying busy on station, continuing to help conduct basically a lot of different activities on board Space Station, whether it be critical research or maintenance tasks. They've touched just about every category of task we have to do on Space Station at this point in time, and it's been really great having them up there and having the extra set of hands to help us out with everything. So really, I couldn't be more proud of how the team has worked together through this. We've had a lot of things go on in a short period of time, and the team has worked really well together across all of the vehicles and everybody on board, everybody within the partnership to get through it. And the entire team will be ready to support Starliner's undocking once they're ready to go. And with that, I'll turn it over to Emily.
Thanks, Bill. And thanks to everyone for joining us today and for your interest in our work here. I would just say that, Butch and Sonny are excited to be on ISS. We are leveraging their extensive spaceflight experience. Of course, they've both been ISS residents in the past, and so they have just seamlessly integrated with the Expedition 71 crew and are contributing a great deal to that mission. They take time out periodically to touch base with the teams that are reviewing the Starliner data. They get to stay up to date on all of the work that's going on as we take a look at their spacecraft, as we complete this test flight and ring out these systems to make sure that we have a full understanding of what the spacecraft is capable of going forward. So they're staying up to date as we work through those various different questions. Beyond that, as Bill said, I could not be more proud of our teams both in space and on the ground. There have been a number of opportunities to come together and work through issues over the last several months, and the teams continue to perform at a really high cadence. We're all excited to continue this work together and get a whole lot done this summer while we have those extra pair of hands on board. With that, I'll hand over to Mark Nappi from Boeing.
Thanks, Emily, and thanks, everyone, for joining us. I'm going to try to do the same thing that Steve did and try to clarify a little bit. Every morning, I've got Google Earth set, and they send me Starliner stories. And so every morning I sit and I read them, and I'll tell you, from being a representative of Boeing and a representative of the Starliner program, it's pretty painful to read the things that are out there. We've gotten a really good test flight that's been accomplished so far, and it's being viewed rather negatively. This morning I did my normal routine, and I was thinking about what I was going to say in my opening remarks, and I stumbled across Ken Kramer's interview on Starliner. He really did a nice job, and it's because he kept it simple and he just stated the facts. So thanks for that, Ken, and I'm going to try to do the same thing as I walk through my opening remarks and clear some things up, explain why we're staying on ISS longer and why it's a win-win for everybody. First, I'm going to repeat the same thing that Steve said. We're not stuck on ISS. The crew is not in any danger, and there's no increased risk when we decide to bring Sonny and Butch back to Earth. Let's recap a little bit of where we are today. We had a really perfect launch and orbital insertion. We've met all our flight test objectives. We had these operational checkouts that were over and above the flight test objectives that we've also completed, and we've added more. In addition, we've learned a little bit more about what an extended duration mission is, and we would have not learned those things had we just stayed up for 8 days. So we're docked and we're safe. We have an approval to be a lifeboat in case of an emergency on ISS. That means we can return with the Starliner at any time, and that was proven this week, as others have mentioned before me, with the conjunction that was identified, and the crew used the Starliner as a safe haven, and if needed, could have returned to Earth. So now, why are we staying longer, and what are we doing? Well, we had 2 anomalies. Everybody knows about them: the thrusters being deselected during approach and docking, and we had the helium leaks. We understand these issues and for a safe return. What we don't understand these issues enough yet is to fix them permanently. Again, I'll say that again. We don't understand these issues well enough to fix them permanently. And the only way that we can do that is take the time in this unique environment and go and get more data, run more tests. So the way we address issues like this is we build fault trees. Sometimes these fault trees have 80 to 100 boxes, and they're all possible causes of why we're seeing what we're seeing. Then we take that data that's available to us and we run tests, and we try to eliminate every single one of those boxes to narrow down to the most probable cause or maybe the root cause. And then once we get down to those few, we can apply fixes to them and eliminate the problem. And that's exactly what we're doing right now. While we have this unique space environment, ISS has welcomed us to stay longer, and the crew's happy to be up there. Let's take the time to learn. Engineering loves data, and this is a really good technical opportunity. Some of the testing that we've done so far, we ran the hot fire test while we were docked, and now we're going to try to replicate what we saw during the docking with a ground test that Steve mentioned earlier. We want to see if we can gain more knowledge and see if it will tell us more about the causes. We want to determine if we should do anything more in flight. Maybe we should try to do more hot fire testing while we're docked. Maybe we want to do something when we do undock with additional hot fires. So running this test will give us more information so that we can make those decisions. This ground test is simply attempting to recreate the space environment and the thruster firing profiles. And we want to look at the results and then determine whether or not we want to do more testing. We may or may not be able to replicate everything exactly as it happened, but we do believe we're going to learn some things from this test with respect to the individual thrusters and help us in our root cause investigation. And that all leads to improving the system for the future. So we have an end-to-end plan. We have a number of actions that have been defined that we're going to go complete. After it's all complete, we'll meet, we'll make sure we did everything we needed to do to understand the system, then we'll come home safely. We're not sure when that's going to be yet because these tests are unpredictable and how long they take and how successful they'll be. So we'll run more tests while we're docked, or we may run more tests while we're docked. We may figure this out and need to do some things after we undock. But when we do figure this out, we're going to return safely, and we'll set a date for that when we figured all this out. Again, we're not stuck on ISS, crew's safe, and we're going to return home when it's time safely. If this isn't clear, please ask us more questions. We want to really leave here today with a good understanding. One last thing, we've had 4 opportunities to talk to the crew. I had one personal phone call with Butch, once with an all-team downlink session where Sonny and Butch talked to our Boeing, ULA, and NASA team. We had one FaceTime with Sonny where she gave us a tour of the ISS. And lastly, last weekend, Butch and Sonny sent us a really nice email about what they've been experiencing up there and what they wanted us to know. And the takeaways from that was they know this is a test flight, and they knew that we would learn, and this is all good, and it's all not unexpected. They're in great spirits, and they're enjoying their stay on ISS, and the Starliner spacecraft has been, in their words, pristine and precise. Thanks, and back to you, Josh.
Thank you all for your opening remarks, and we'll now turn it over to the question and answer portion. As a reminder, you can press *1 to enter the queue. We are asking if you could ask one question at the start. We'll answer all those, and then if we have time, we'll come back around within the hour that we have. That way we get to as many questions as we can as time permits. And with that, we'll start with our questions, and we'll go to Gina Sinceri at ABC News.
Steve and Mark, I appreciate your comments that the astronauts are not stuck or stranded on the space station, but I'm trying to I'd like you to understand that we feel like we're operating in a vacuum out here. We don't get on-camera briefings. We have not heard from the crew since they've been there. So people are trying to read the tea leaves, and literally in the absence of information, conspiracy theories flourish. So what can you do going forward to keep us more on point on this story?
I'll start, and then maybe Mark can add. I mean, I think we probably need to be doing a little bit more frequent interaction with the media to keep you up to date when we know something a little bit more, like we did today, where we talked about the addition of the White Sands test facility. Hot fire testing, we need to continue to do that more frequently, just to make sure that the media doesn't take off in a direction that, because of a lack of data provided by NASA and Boeing, you try to fill in the gaps. We should be providing those gaps for you. And I'll turn it over to Mark.
That's a very fair comment, and I think we need to take that and develop a better strategy on how we communicate.
And our next question is from Bill Harwood at CBS News.
Yeah, thanks very much. Steve, I mean, I understand they're not stranded. I get that completely, but given the uncertainty about the root causes of the helium leaks and the jet firing issues, how confident, how sure are you that the Starliner is safe to come home as is, given the uncertainties that are obviously still out there in terms of root causes? In other words, is it safe now, or is there any question about that? I think part of the problem here, as Gina was referring to, is you've said it's safe to come home in an emergency, but that's different from saying it's safe to come home when everything's normal, if that makes any sense. And I'll leave it at that. Thanks.
Yeah, I would say, Bill, that when we say it's safe to come home in an emergency, we have confidence in the Starliner systems that the vehicle will go execute the SEP sequence with no problems, and get to the deorbit burn with no problems, and then execute a deorbit burn. And once the service module obviously has jettisoned, then it's the crew module, which doesn't have any significant issues or anomalies at all. I think what we really want to do is, since it's a new vehicle, new spacecraft, we want to take a little more time to understand the thruster performance. In particular, on the crewed flight test, these thrusters have had more pulses than we've had in the past. They have gone through an aggressive qualification program. 2 engines have had over 4,000 pulses put on them. The pulses were put on those engines in a different sequence, and so the heating may have been different. So we want to take a little extra time to understand the performance of the thrusters on the ground, to do this ground test that Mark talked about as well at White Sands, and then take a closer look at the thruster itself. I think we've moved in the CCP program into a little bit more test-oriented program as compared to Space Shuttle. Space Shuttle many times just sort of leveraged the emergency systems or the contingency systems on the vehicle, and at times came home. And here we want to take a little bit more time to understand the thrusters and come home. In addition, in Space Shuttle, we had a limited life with the fuel cells, and we had to come home at a certain time. Here we have the benefit of being docked to the space station, which provides power, life support, and so forth. So we're going to take a little extra time, do this thruster testing, look at the thrusters with experts from the vendor, from Boeing, from NASA, and just to make sure that there's nothing out there. We don't see anything in any of the data so far. The thrusters are performing well, a little lower thrust than expected on a few of them. But when we fire them, like I talked about, we fired one thruster 575 times after we re-enabled on docking day, and we need about 200 pulses of some of these thrusters for the deorbit burn. So we're just taking a little extra time, as Ken said, to do extra engineering work and make sure that we haven't missed something.
And our next question is from Jackie Waddles at CNN.
Hi, folks. Thanks so much for taking my question. Question for Steve or for Mark, I guess. I guess I'm just hoping we can gain a better understanding, too, on why we don't have more of a sense of the return time. So, Steve, I know you said you're looking at bumping that maximum up to 90 days, if I understood you correctly. So does that indicate at this point that you guys are definitely looking to take a full 45 at least? Do we have any more information on, projected timeline for the end of this mission? And then just as like a related point, I'm just wondering, with this additional ground testing you're doing, if that might relate to any changes that you could make on the vehicle while it's in space. I guess I'm just looking to be able to give my audience a sense of what data we're still getting from the spacecraft in orbit. Thanks so much.
Yeah, I'll adjust the timeline. Maybe Mark can take that second part of it. I mean, the timeline really is driven by how rapidly we can execute the testing at White Sands and then do the thruster inspections. I had the privilege of working at White Sands for part of my career. This test is a little different than what we've done in the past. It is going to be in the same thrust chamber that is used for acceptance hot firing these thrusters for flight. However, we're trying to replicate a pulse train from what we saw on orbit and getting that pulse train defined. We've already defined the thruster that we want to emulate during the test. We've starting to build the pulses and check those out. But it's a more complicated test than we've done in the past on thrusters because we want to replicate a certain pattern of when the thruster comes on, when it goes off, and that whole timing. And so that's taking a little bit more time to figure out how to program into the White Sands system. The White Sands team is very talented. I know they're going to figure out how to do it, and they already have. And so we're just looking at the timeline to execute that test and then review the data. And that's what's really the long pole, I would say, in determining a landing date. And I'll let Mark answer the second part of the question.
I'd add to that, the test is currently under development. Just defining the requirements and exactly how we want to run the test. And so, there's some uncertainty of the content of the test when you're still under requirements development. That could change the duration. Once you run the test, especially these first-time tests, you're going to have to expect some surprises, which will change the duration. Those two added together, just have us guessing at when we're going to be done with the test. Then there's review of the data afterwards. All those things together makes it impossible for us to say that it's going to come down at this time or we're going to have a decision at this time. Once we get further along, I think we'll be able to do that. But right now, don't want to box ourselves in with another date that's just a guess. On changing the vehicle, there's very little possibility that we're going to change the vehicle or even have the opportunity to change the vehicle, and that this test would have us change the vehicle. So I would think that's just probably a very low probability or low opportunity to change or to fix anything. I should say change anything.
And our next question is from Joey Roulette at Reuters.
Hey, thanks. I just want to agree with what Gina said. I think if NASA engages a little bit more with reporters beyond its blog posts, I think that would go a long way. Question for Ken or maybe Bill or Joel. I have a Starliner question, but hopefully I can get back into you later. But for now, did Russia provide any explanation to any NASA office for its Rusers P1 breakup this week? Thanks.
I've got no information on that topic, Joey. Thanks for asking. Anybody else that might have received information on that topic?
No, we haven't received any information on that.
And our next question is from Kenneth Chang at the New York Times.
Hi, thank you. This is for Steve and Mark. I just want to give you the opportunity to be, I guess, a little bit more emphatic about what you're saying. That not only this is what you should be doing with the Starliner testing, but it would be effectively irresponsible if you weren't doing this, and that the really bad days at NASA were when the mission managers didn't seek more data or ask the questions where they thought they knew the answer already. Thank you.
Hey, thanks for saying that. We are trying to do this mission right. We're trying to explore all the avenues that we have a reasonable amount of time to explore. And I really value your comments and that you see what we're trying to do.
And our next question is from Jeff Bloomfield at National Public Radio.
Hi, guys. Thanks for doing this call. First of all, I mean, if you can't commit to a return date, you can't tell us not to use the word stuck. I mean, that's just ridiculous. But anyway, that aside, you know, the big picture here is certification, right? Dragon got certified about 6 months after its second test flight. Boeing's already had to have an additional test flight. I can't imagine you're going to do certification in 6 months. And, you know, Boeing's hemorrhaging money. Is this the end of the Starliner program? Can we call it quits?
Yeah, I'll comment first and then let Mark comment. You know, we realize that it's going to take longer than we originally planned for certification. We have the teams today, both the Boeing and NASA teams, focused virtually 100% on the crewed flight test, other than Mark will talk about the team in Florida that's assembling the vehicle for Starliner 1. That service module is being built, and then the crew module is undergoing some refurbishment activities. But we understand that it's going to take a little bit longer. But the data we're learning on orbit and with the test at White Sands is certainly going to help us towards certification. Obviously, we didn't expect to have this thermal issue with the thrusters where we may get some vaporization and have the low thrust, and so it's something that was missed, and we've got to address for certification. We're collecting that certification data in the best way we can, which is analyzing the current mission and then making changes going forward, both for the thrusters, not new thrusters, but maybe the way we're firing the thrusters, and then also the helium system. And I'll let Mark comment on the rest. By the way, I see a total commitment from Boeing on this flight with all the resources that they need to ensure that we get the vehicle back with the crew safely. Go ahead, Mark.
I agree with everything you just said, Steve, and the plain and simple answer to the question is no. We're not going to back out. This is our job, and this is what we're going to continue to do to meet our commitments.
And our next question is from Micah Maidenberg at the Wall Street Journal.
Thanks a lot, Josh. Just real quick, I'd like to chime in to agree with what Joey and Gina said about communication. But so anyway, Steve and Mark, have the issues with the thrusters and leaks prompted you guys, the team, to analyze any other systems that are going to be used on the next leg of the trip back, besides the service module, of course? I mean, do you need to recheck the parachutes or anything else that we haven't been talking about, given how the leaks and thrusters, the challenges with them emerged? Thanks.
I can start with that, Steve, and then you can jump in after if you'd like. The majority of the systems that we need for return are what we used to get to orbit and to get to docking. So, and they've performed very well. So there's no reason to believe that they're going to operate any differently on the way back home. Obviously, the airbags and the parachute systems have not been used and won't be used until landing, but those systems have gone through pretty extensive testing as recent as last January, and with a lot of confidence that they're going to be working properly. So there's no need to go back and do anything differently.
Yeah, I'll just add that agree with everything Mark said relative to the parachute system and the crew module. All the flight computers on the crew module are performing well. The integrated propulsion controllers, all the systems on the crew module. Parachutes, as Mark said, we've done an extensive amount of certification, went through in detail all the documentation provided by the supplier and Boeing. Don't see any issues with the parachute system. And then the thrusters on the service module are not related at all to the ones that will be used on the crew module for entry. It's a different thruster, a different pressurization system, uses nitrogen in a different way. So the systems are so dissimilar that we don't see any crossover. We just really need to make sure that the service module does its functions for the separation and the deorbit burn. And then, the most aggressive part of the flight for that service module was the docking phase. There's more pulses required in close to station in that final phase of the approach, and then stopping at 10 meters than there are for the deorbit burn. So the service module has had its workout, so to speak, on docking day, and we know that the requirements on it are less for the remainder of the flight.
And our next question is from Will Robinson-Smith at Spaceflight Now.
Hi, thanks so much. Also just wanted to echo Gina, Joey, and Micah's comments and to say that, as Ken Bowersox mentioned at the top of his comments, a lot of stuff going on with the station, including the deorbit tug contract that I'm sure we'd love to learn more about. So hopefully there will be another separate briefing on that in the near future. But regarding CFT, if the tests at White Sands don't yield as much information as you'd like to know to fully characterize the thrusters, I guess, how far out or how long do you anticipate a test campaign on those could last, and what are the knock-on effects directly for this mission and the future of the program, would you say? Thank you.
I think right now we think the testing could take a couple of weeks. We're trying to replicate the in-flight conditions as best we can on the ground. We know we have some limitations already. We're going to take that data and then really compile it with all the other data that we have on the thrusters, not only from this flight, but as I spoke of on OFT-1, we had a number of thrusters that pulsed well over 1,000 times early in the flight. We'll look at that data plus the data from this flight and compile it all together. We could go another week or so in the testing at White Sands if we needed to. We have 2 thrusters there that we can test. So I think we just need to get through this first set of tests and see how it goes and what we're learning from those tests.
And our next question is from Michael Sheets at CNBC.
Hi, everybody. For the White Sands testing here, I'm particularly interested why this needs to be completed before the return happens if you're so confident in the safety of the return happening. This seems like something that you guys would perform outside of any other normal testing, either before or after a flight like this. So explain to me, because there's a bit of a disconnect between you guys saying everything's going so well, they're not stuck, they're doing great, vehicle's totally fine, and then saying, oh, we actually have to spend weeks to complete testing back on the ground before you can bring them back. Secondly, just to reemphasize, please, updates in the morning and are really appreciated. Press conferences really appreciated. Everything my colleagues are saying is really important here, that we get regular and direct updates. And secondly, off of that, I'd really ask that NASA holds another press conference with Bill, because I'd love to hear Bill talk about the U.S. deorbit vehicle as well as SpaceX representatives about their nearly $1 billion contract. But today, the most important thing is Starliner CFT. So I'm just asking off of that, we get a second press conference that's separate. Thank you.
Yeah, Steve, let me try on the test. So I tried to articulate this up front, is that, doing this, we've built a fault tree. We've got a number of causes on that fault tree, and we've crossed them off. This test is going to cross off more, and it's going to give us information to potentially do some things while we're still docked to station. So if it comes back and gives us all the answers, then we can just undock and come home. If it comes back and says that here's 80% of the answer, and if you just run one more docked hot fire, then you can get 100% of the answers. Then we want to be there so that we can get that information. So it really is more of a serial test than a parallel test.
Yeah, and I would add that the one thing that we can do at White Sands that we can't do on orbit, we can run more hot fire tests and we can get data on the thrusters on orbit, but the White Sands testing gives us the opportunity to physically look at a thruster. All the engineering data suggests that the thruster is performing well. All the engineering and other qual data where we've run one thruster, the vendor has run it up to 7,000 pulses. All that data suggests that this thruster should be healthy, but this is a unique set of pulses we put in the thruster, and the team wants to make sure by looking at that thruster at White Sands physically with inspections and borescopes and so forth. And so, as Ken pointed out, we have a great opportunity while docked at the space station to go collect this data and then have it before we return. If we need to return before then for an emergency, we will use all the data that we have in hand today on the thrusters, and we will, base that data suggests that the vehicle should be just fine. But we want to take a little extra time to get this one extra set of data on the ground, if that makes sense.
And our next question is from Jeff Faust at Space News.
Good afternoon. I'll plus one the comments of my colleagues about the need for more frequent and more thorough briefings and updates. But for Steve, you mentioned a little earlier in the call that you acknowledged that certification of Starliner is going to take a little bit longer than you expected. At what point do you have to make a decision about what vehicle to fly in that early 2025 crew rotation mission to ISS, whether Starliner will be ready or you'll have to move up Crew 10? Thanks.
Yeah, good question. I think we've talked about, we have a parallel path right now with Starliner 1 and the Crew 10 vehicle for that February slot. So we're still proceeding with that parallel path. We can take our time and get through the crewed flight test and have the vehicle return with Butch and Sunny, and then we can make a decision afterwards, even if it's a little later than we originally thought. So we still have time.
And our next question is from Eric Berger at Ars Technica.
Hi, switching gears just a little bit, since we've got Bill Spetch on the line. What is the architecture for the US deorbit vehicle? Is it going to be a modified Dragon, a Dragon XL, or something else? And secondly, can we get a little more information on the 2 EVA cancellations, the suit discomfort and water leak? Was there commonality? Is this due to aging spacesuits? Was there a problem with the preparation of the suits, or was it something else? Thank you.
Yeah, so on the US deorbit vehicle, that's based off a Dragon Heritage design. Obviously, they have to do some modifications and some changes to the trunk for that, but that is the plan for the USDV. On the EVA side, the two different EVAs were not related in terms of the various failures. So this latest one, I wouldn't say it was due to aging or of the suits or anything along those lines. It's a moving part within this umbilical, and sometimes those stick, and so we have to go take a look at what happened to cause that one to stick open and let the water kind of flow out.
And our next question is from Irene Klotz at Aviation Week.
Thanks. This is, I think, for Steve. So you've already been asked this a couple times, but it still seems a little nebulous in that you have said that Starliner is completely safe for deorbiting, even if you needed it because of the debris incident, or presumably any time that there'd be an opportunity in the four-day landing rotations. But you've also said that there's a little more work to get there before the final return. So it sort of sounds like one of these little bit pregnant things as to the comfort that you would have if you needed to deorbit ahead of getting this additional test data out of white sand. So could you maybe take one more crack at the difference between bringing Starliner back right now with whatever data you have versus waiting and perhaps tweaking the deorbit plan in some ways with the additional data? Thanks.
Yeah, I would say it this way. I mean, the test will help us understand the thruster performance, and it may give us 100% confidence that everything we've seen on orbit is fine. It's just one more piece of data that we can have before we actually deorbit the vehicle. And as Mark said, there's a couple things we can do to tweak the deorbit if we had to. We can actually tell the vehicle not to fire certain thrusters if we do a test and we see one of these thrusters that we have on orbit is not performing exactly the way we want. We could actually deselect a thruster, or we could change the thruster firing sequence that holds the attitude for that deorbit burn a little bit. So we have a little bit of time to do that. But today, if we were in a contingency situation where the crew absolutely needs to come home, where the space station is not a habitable environment, the engineering data suggests that the thrusters will do fine, and the thrusters will perform well, just like we did on rendezvous day when each of those thrusters that had an issue, except for the one we've deselected, fired, between 200 and 500 more times. So hopefully that makes it clear, and see if Mark has anything to add.
No, Steve, I think you explained it well. Thanks.
And our next question is from Elizabeth Howell at space.com.
Hi, I'd like to echo that the lack of updates has been a little bit difficult, but I do appreciate everyone's time today. This is probably for Mark. Can you give a bit more clarity about that 45-day limit for the batteries on Starliner and how you're able to evaluate the life and the recharging capabilities to get it to 90? And also if that could even persist further, say if you wanted to go for however it may be, a 180-day mission or whatever, how would you be evaluating that going forward? Thank you.
Steve, I think your team is evaluating the extension. Would you like to comment?
Yeah, I'll go ahead and take that one. We put a number on the flight, said 45 days based on the risks associated with this certain battery, and given certain failure modes that could happen. And what we really are doing now is looking at the performance of the battery in flight. We don't see any degradation in any of the cells. The batteries there's like 12 different batteries. There's 500 cells per battery. Each cell goes through a very scrutinous screening process prior to flight. We let it sit for like a whole year to make sure that it doesn't have any defects in it. We do scans of the battery cells. So we know that the battery cells that we have on orbit are good based on the data, and so now we're just looking at that risk levels, and the risk on any given day is the same, and so you can extend essentially that 45 days for another 45 if we decided that we were going to do that. We haven't decided how long to extend it yet, but I was just saying the risk of any given day on a given number of the cells in the battery is the same, if that makes sense.
And our next question is from Chris Epperhart at Fox News.
Hi, thank you guys. I just had two really quick questions. One, I just wanted to see if it's possible that we could do something like this with a video conference with the two astronauts, if we can arrange it like this, just so we can hear directly from them how they're doing. And the second part of that is, have you been in contact with the astronauts' family? What have they been saying? Are they expressing any sort of concern?
Yeah, this is Emily. We, in terms of communication with the families, we keep them up to date. We have specific astronauts that are here on the ground that are assigned the task of making sure they're kept in the loop. And then, of course, Sunny and Butch and all of our crew members on board are effectively able to make phone calls whenever they have some free time. So in addition to the regularly scheduled personal conferences that we set up with their families, they're also able to chat pretty much any day. I mean, and so the families are really kind of involved every day in the mission as we go along.
And our next question is from Marcia Smith at spacepolicyonline.com.
Thanks so much. And I would also like to echo what all my colleagues have said about how useful it would be to have more of these conferences. And as much as I appreciate this one today, I think trying to do all three of these topics at the same time, the EVAs, the Starliner, and the deorbit vehicle, is a bit of a challenge, all within 1 hour. So as others have suggested, I hope that you will do separate telecons or even press conferences, in-person press conferences on at least the deorbit vehicle and even the EVAs. That would be very helpful. But for just now, I have been trying to find out about the second EVA scrub and about Dyson's spacesuit. Is it correct to call it a spacesuit failure, or is it a failure of one of the ISS systems? Exactly what is it that failed? And Bill, I think you said that you were unable to replicate it. Could you talk a bit about how you went about trying to replicate it and just explain that more? Thanks.
Yeah, sure. The part that we had the leak on is an umbilical that connects to the spacesuit. So you can imagine I have a set of cables and hoses that all are bound together that hook up to the spacesuit to provide services to it. And one of those lines is water that goes to the spacesuit for cooling. And so that has, because obviously when I connect it and disconnect it, it has these poppets that are supposed to close whenever it's not connected so that the water doesn't drain out. The water that we saw draining out was on the umbilical side, not on the spacesuit side, but it sprays water all over the place, as you can imagine, as it came out. And so we have to look at both sides of the interface after that fact to make sure that we were good with what happened.
And if I can add,
Yeah.
This is Emily again. It's not at all unusual for us to see this type of failure in fluid connections. Our standard training for pretty much any fluid connection for the astronauts on board is that they should not be surprised if the poppet, the thing that moves back and forth to either allow water to flow or to prevent water from flowing, gets stuck. In terms of causing it to get stuck, that's just not something that's easy to do. And since this is the first time we'd ever seen that happen, you try to go and actuate it again and you can't get it to fail again. That also is not unusual, given that this is not a pretty regular failure mode for this particular connector. But for fluid connectors across the station, this is not an unusual behavior. We just need to understand this particular one in more detail before we can get the crew lined up to try again.
Yeah, and just, we did a number of troubleshooting steps once we got in. We looked at we connected it and disconnected it like 6 different times, sometimes with the line pressurized, sometimes with it not pressurized. So we tried a number of different ways to see if it would just continue to happen. But since it didn't do that, like Emily said, it's pretty rare that we get into this situation. So we have to go think about it some more.
And our next question is from Manuel Monzanti at Exploración Espacial.
Thank you, Josh. Manuel Monzanti, Exploración Espacial. I had like 4 or 5 questions about CFD, but they were all answered. Thank you for that. And I have one regarding ISS deorbiting, and I agree that we should have another call. But what would be the process of using this SpaceX vehicle? And I'm sorry if you mentioned this in another call or previous call. The idea is to use this vehicle for deorbiting the space stations all at once, or are you undocking by sections or by modules? How will be the process? Thank you.
Sure. We will do the ISS all at once. It would dock to the orbit vehicle will dock to the space station. We'll gradually lower the altitude of space station until we're ready to perform the deorbit burn, and then this vehicle would execute that deorbit burn to bring the whole thing in all at once.
Our next question is from Anthony Leone at Spectrum News.
Hello, thank you for taking the time to answer questions. This is for Steve and or Mark. If there's a benefit in keeping the Starliner docked to the ISS and collecting all this data, would NASA and Boeing consider returning Butch and Sonny on a different space capsule to allow the Starliner team to work and learn more about these issues while Calypso was docked to the station?
Yeah, I'll start and then Mark can add. Right now we're focused on returning Butch and Sonny on Starliner. Obviously, we have luxury of having multiple vehicles, and we've worked contingency plans for lots of different cases. But right now we're really focused on returning Butch and Sonny on Starliner.
I see no reason to do anything differently as well. And I think we just need to reiterate, the vehicle's safe for return. And like the gentleman said earlier, it would be irresponsible for us if we have time and we want to do more, not to do it.
And our next question is from Tim Fernholz at Payload Space.
Hi there. I just want to join my colleagues in saying more information is better. I think we all understand what happens when NASA makes an announcement after 5 p.m. on a Friday without a press conference. I'm just curious, since the June 18 discussion, when specifically was the decision made to do the terrestrial hot fire testing on the thrusters? And what were the circumstances that led to that? Was there specific data that led the engineers to conclude that testing was necessary? And also, what is the progress of the agency-level review, and will that require Administrator Nelson's sign-off? Thank you.
Yeah, I would say on the hot fire testing, we started preparing the test stand a number of weeks ago, just in case we might need something. Probably, I'd have to go back and check my records, but so after probably the week of June 10th, we started talking about, hey, we should go reactivate the test stand at White Sands. We needed it anyway for hot firing thrusters for Starliner 2, so we did that. And then just as time progressed, as we started understanding what our capability would be at White Sands, could we really replicate the thruster profile that we saw on the uphill leg and what's required on the downhill leg for the deorbit burn? Once we started to understand that capability, the engineering teams convinced the management teams that both on the Boeing and NASA side that it was wise to go do a test. We looked at the station timeline and what was going on station. Could we keep the vehicle docked for a longer period of time? There was really no constraints there. And so, more data is always better. It's always responsible to collect all the data you can in a situation like this. And so we made the decision. And I'll see if Mark has anything to add.
I think I understood the question a little differently. I think the question was, when did we decide to do the docked hot fire tests? And, that decision process was, we looked at wanting to do another hot fire. We talked about doing it after we undock. And, of course, we did them prior to docking, and we got a couple of them back. After we had discussed it on the Boeing side, we really weren't aware so much work had been done on station to be able to do docked hot fire testing. So once we learned that all that work had been done and we could do it on the vehicle, we said, well, yeah, let's go for that, and let's fire these thrusters and make sure that they're working properly.
Our next question is from Megan Bartels at Scientific American.
Thanks so much. Can you hear me okay?
Yes.
Excellent. I just want to echo everyone else on their comments about speaking more with media, both in terms of Starliner and the deorbit vehicle. And my question is actually on the deorbit vehicle and for Bill. Could you talk a little bit about what set SpaceX's proposal above the competitors and when NASA and SpaceX will provide additional details about the design of the deorbit vehicle? Thanks.
So obviously we can't talk about selection criteria. You can look at the source selection statement when that comes out to gain insight into that. I don't know exactly when we'll be able to talk about more of the design details associated with it. They have to go through a design process, obviously, and we'll be working through a process with them as part of the execution of the design and build. And we'll keep you updated.
Our next question is from Clayton Sandel at Scripps News.
Hey, thanks for doing this. Anytime we have broadcast or posted a story on Starliner, one of the most common comments we see from our audience is, why did NASA and Boeing launch a spacecraft they knew had problems? And now you have mentioned this narrative that has dominated the last week about astronauts being stranded. It's bringing more attention to Boeing's public image. And I guess this is a big picture question for Ken, Steve, or Mark, and that is, in hindsight, how much are you second-guessing or regretting the decision to fly this spacecraft, perhaps prematurely, given the problems that it was having?
I can start and then see if Ken and Mark have anything to add. I think many of the things that we're learning would have been difficult to learn on the ground. And so I personally don't have regrets at launching the vehicle and docking with station. The helium leaks, when we looked at the system on the ground, we only had one flange leak, and our experience on the previous flight was that we only had two really small leaks that we thought maybe were caused by something else. So we learned about those helium leaks. I think those are going to be manageable with the amount of margin we have. And then the thrusters, certainly we did a few more maneuvers on this flight than we did on the previous flight. We thought we had made some software correction changes to eliminate the fail-offs that we had on OFT2 while we were sitting at 10 meters. We clearly missed something. We clearly have an integrated effect between how we're executing the rendezvous profile and how we're using the thrusters, and so I think we learned something there. We'll work through these two items and have the right level reviews, including an agency level review when it's time. And then we'll bring the vehicle back. So I personally do not have regrets, and I'll see if Mark and Ken have anything to add.
Yeah, I will say the same thing. We're running a test, and no regrets on the decision to launch and get into the test flight. The job I had before this was to lead the green run of the core stage at Stennis. And of course, we were using the flight vehicle to do that. And there was a lot of nervousness going into that test because it was, quote, the golden egg. It was the flight vehicle. And, we had lots of discussions, are we ready? And we all realized that at some point you have to run the test. You're running the test to learn things. And you have redundancies in your system in case you were wrong on some things. You have very well trained people to deal with things if you were wrong, and you have tighter tolerances usually with these test vehicles, so that if you get outside the tolerances, there's less of consequences. So I think we did the right thing, and I think we're learning, and we're going to improve the system for the future.
Yeah, and this is Ken. I don't find regret a very productive emotional thing to go through. I think instead I ask myself questions like, did we follow the right process? Did we include all the members of the team? Is our approach healthy? And when I look back, I think we did go through all the things that were appropriate prior to the mission, and we were open to anybody that might have had a different opinion that thought we should be doing something differently. I also was really impressed during the pre-flight reviews. People asked the question, well, what if what we're seeing now gets worse? Is there a way for us to counteract that? And they came up with procedures to counteract the situation if it were to get worse. So I think all of that was very healthy. And then when it comes to the question of safe, unsafe, somebody who some of you may not know, a guy named Mike Serber, has a sign on his wall. He's the safety officer for the International Space Station. And he said, space flight is neither safe or unsafe, but it is incredibly unforgiving. And because of that, you need to be very serious about every decision you make and gather the data when you have time to gather the data and do all the analysis that you can. And that's what we're doing in this case. The real question is, are we willing to put our crew on the spacecraft to bring them home? When it is a contingency situation, we're ready to put the crew on the spacecraft and bring them home as a lifeboat. For the nominal entry, we want to look at the data more before we make the final call to put the crew aboard the vehicle. And it's a serious enough call that we'll bring the senior management team together and, again, go through that process that I talked about just a minute or so ago.
And we have time for one final question, and that's from Ryan Caton at nasaspaceflight.com.
Hi, thanks very much. I'll just also echo the comments earlier that more information is always better for us doing our jobs as well as you guys doing your jobs. My question, I think, is probably better suited for Steve and or Mark. If your ground testing at White Sands with the thrusters show results which you don't want to see, what are your options for bringing the crew home? Does Starliner's deorbit now require a positive result from the testing at White Sands? Thank you.
I'll start and see what Mark has to add. I mean, I think we want to learn at White Sands when we put a thruster through the profile. Can we, at the end of that testing, can we look at the thruster? Right now, the data on orbit suggests in 4 thrusters that have had different experiences of how many pulses they had, when they had the pulses, and what temperatures they were exposed to. They all appear to be healthy. They all appear to have been able to sustain quite a number of more pulses, including one that had 575 more pulses after it was recovered. We want to really look at the thrusters at White Sands afterwards and inspect them just to see if there's any untoward effects. I don't think we expect that. Obviously, if we had some result that was unexpected, we would stop and talk about it, right? That's part of the way we do business. Do we need to test another thruster? Was that a problem with the thruster itself or the test setup? Again, this is a test that is typically done with a thruster, but maybe not quite in this way where you're trying to replicate and duplicate exactly a long series of pulses over a number of days with the thruster. And I'll see if Mark has anything to add.
I think Steve made a good point. Our docked hot fires came back, and it appears we have good thrusters to come back with 4 of the 4 that we tested. We didn't test the 5th one. The team has looked at this test, and they're very confident we're going to learn some things from this test. There's a range of how much we're going to learn, and based on how much we learn will again dictate what we do additionally. In the event that we learn something on the negative side, then we're going to stop and talk about it. And I wouldn't even try to guess what that might be. We feel we have pretty good hardware right now, and this test is to help support that theory as well as give us more information for root cause.
And I'll now turn it over to Ken Bowersox for some closing comments.
So I just want to thank you all again for listening in today and asking your questions. One of our main mission goals is to share the information from our space flights with the public, and you're a critical part of that. So we heard your comments about how we share information, and we'll take them into account. We'll see what makes sense. There have been times when we had a press conference every day during missions, right? And maybe that's something that we need to go back to when we've got vehicles up on orbit, especially during test flights. We'll take a look and see what makes sense. But I also want to impress on you that the team is just incredibly busy. It takes a lot of time to prepare for these conferences, and so we want to give them the time to do their work so that we have the best chance of getting the data we need on this test mission. But we'll see what we can do. There's probably something we can do to step things up, and I especially appreciated the comments on timing for even our blog posts, what time of day it helps you for them to come out. So don't hesitate to keep sharing that with our OCOM team, and thanks again for joining us today.
And this is Josh. I know we didn't get to everyone's question that was dialed in today, you can reach out to me online, and we'll be able to answer those questions for you. We'll also look to provide more on our next update publicly. And with that, that's going to wrap things up for us today. Have a great afternoon.